Hi everyone and welcome back. This is our section 6 for chapter 2, solving absolute value equations. We've talked about absolute value a little bit and we're going to get into what we've talked about in just a second, but first the objective here is solve equations in one variable that contain absolute value expressions. So here's a warm-up. Take a minute, hit the pause button, hit spacebar, come on, go through these problems and then come on back. And there's the bell. Going through the answers here quickly. Number 1, add 10 to both sides, or bring this over and make this plus 10. X is 14. Same with number 2, bring the 5 over, make it negative. This is going to be negative 7. S equals negative 7. This one here, divide both sides by negative 8. Y is going to equal negative 4. Next one, get rid of the fraction first, so you have to multiply both sides by 2. And then move your negative 4 over to make it negative 4. Your final answer here, M is going to be, make that, there we go, 10. Down here, move this over, make it a positive 5. It's one too many 5s. Make it a positive 5, and you get x equals negative 9. And this one, number 6, is a two-step. Bring this over, make this a minus 5. 2t equals 40, and then do a simple division. T equals 20. Okay, so let's get to it. Absolute value, and we've talked about absolute value before. It's a value that's always represented as a positive number, and what it means, it's the distance from 0. A number is away from 0. So over here, the absolute value of negative 3 is 3, and the absolute value of 3 is 3, but any number inside those brackets is always going to be positive. Now, solving for the variable, we have to usually find that the variable can have two possible results, and you'll see what I mean here. If absolute value of x is 5, then what could x be to give us the absolute value of this number x to be 5? So what we're going to do is, well, if x equals 5, absolute value of positive 5, well, that's 5. And then what if x is negative 5? Well, the absolute value of negative 5 is also 5. So what we're running into in this section is looking at two possible answers in some cases that our variable could be. And once again, absolute value is the distance this number is away from 0. So if you have an absolute value of 5, whatever your number may be, that's how far you are away from 0. That's why if you take 1, 2, 3, 4, 5 steps, you're at negative 5, and then 1, 2, 3, 4, 5 steps, you'll be at positive 5. You have a difference of 5. But either one of these values, the absolute value of negative 5 is 5, and the absolute value of positive 5 is 5. So what we're going to have to just check here in the end to make sure that there's going to be probably two different answers for our variables. Okay, so let's take a look at our first equation. And what we have to do first, always, is to get this absolute value alone. Okay, this little bunch here. So everything else has to go. So we're just going to kind of treat this as its own entity here and work around it. So the first thing I have to do is get rid of this 4 on the outside. Now, even though these aren't technically parentheses, this is still a multiply here. So to get rid of a multiply, there it is, we have to do the opposite. We have to divide. So I'm just going to do a simple division like this. Or if you feel the need, you can bring this over, and I'll clear this out. You can bring this over and here we go, and make this a divide by 4. Whatever way you like, traditional, non-traditional method. So when I'm done with that, I'm going to have absolute value of x plus 2 equals, now 24 divided by 4 is 6. So now I've isolated my absolute value quantity. It's all by itself. So this one, I'm going to have to set it up into two different equations. Okay. Now case 1 here says, well, okay, the absolute value of x plus 2 could be 6, but case 2 is saying the absolute value of x plus 2, there we go, could also equal negative 6. So what I'm going to do is, well, I'm going to just solve for these. I'm going to get rid of the absolute value brackets and say, okay, well, x plus 2, I'm going to just bring this over, make this a minus 2. and have x equals 6 minus 2, that's 4. And then I'm going to do the same to the case 2, x plus 2 equals negative 6, and I'll bring this over and make this a minus 2, get rid of that. So x is going to equal negative 8. So here I have two separate answers. Why do I have two separate answers? Well, let's do a quick check here and we'll see why. So here's my check up here. So I'm going to do 4 times the absolute value of x plus 2 equals 24. So let's just plug in one of these numbers here. Let's try our case 1 answer and we'll plug in 4. So when I do this, I'm going to have 4 times the absolute value of 4 plus 2 equals 24. Probably going to run out of space here. So I'm going to do, now I have 4, and this is going to be 6 equals 24. Well, absolute value of 6 is just 6. So I'm going to have to clean this up just a little bit here, make some room. Get rid of these arrows. So 4 absolute value of 6 is going to be 6. Hey, 4 times 6 is 24 equals 24. That's good. Let's check case 2. We'll over here on the far right. 4 times the absolute value of x, and this time x is going to be negative 8 plus 2 equals 24. So again, I have 4 and then negative 8 plus 2. Signs are different, so we're going to subtract. Sorry guys, we had a bit of a glitch there, but I'm just going to pick up right where I left off there. I was checking my answer for case 2, x equals negative 8. So I was plugging that in and doing 4 times negative 8 plus 2 equals 24. So again, this absolute value, we're going to do that first, just like it acts like a parentheses. I'm going to do 4 times the absolute value of, now negative 8 plus 2, that's going to be negative 6. Signs are different, subtract, keep the sign of the bigger number, equals 24. So I'm going to take care of my absolute value. My absolute value of negative 6 is just 6. So 4 times positive 6 equals 24. So 4 times 6 does equal 24. And that's okay. That gives us a check. And everything checks out. Let's look at the next example. This one here is, pop it up here, absolute value of x minus 3 equals 4. So once again, we're going to isolate our absolute value. So that means we got to get rid of this, toss it over to the right side, and make it a positive 3. And that goes away. So again, I'm left with the absolute value of x equals 4 plus 3, which is 7. So once again, I have two different answers here. My absolute value of x, my x could be, x could be 7, what we have it to be right here, or my x could also be a negative 7. There's no actual work we have to do anymore. If we just want to check that real quick, just to plug it in, the absolute value of 7 equals 7. So that's it. Then check it out. Oop. Absolute value of 7 is 7. So that's a good thing. And check the other side here. If I take the absolute value of x, which is negative 7, equals 7. Absolute value of negative 7, hey, that is 7. So that one works out as well. Do another example here. 8 equals the absolute value of x minus 2.5. Now for this one we have nothing to get rid of with our variable. Our not variable, but our absolute value term is already isolated. It's all by itself on this one side. So we're going to split this up again into two cases. So our absolute value, and we're going to have to write this on, get that first, of x minus 2.5 could be 8, or our absolute value of x minus 2.5 could also be negative 8. It's opposite. So just a quick one-step solution here. Make this a positive 2.5 plus there, and then for this one on the right, bring this over, positive 2.5 minus 8. So this is going to give us an answer of 10.5 equals x. And this one on the right will be negative, signs are different, 5.5 for x. So again, if I just want to do a real quick check, won't take us long at all. 8 equals the absolute value of x minus 2.5. Plug in 10.5. 10.5 minus 2.5. Keep going here. 8 equals absolute value of 10.5 minus 2.5 is 8. The absolute value of 8 is 8. So both sides are good there. One last check over here. We're going to do, I'll do some kind of a purple. Negative 5.5. Nope. Go back here. 8 equals x minus 2.5. So 8 equals the absolute value of negative 5.5 minus 2.5. That's going to give us an answer of 8 equals the absolute value of negative 8. And the absolute value of negative 8 is 8. So we're good there. Let's look at another one. This one will save time. We won't have to check the answer. So once again, we're trying to get that the absolute value of a term all by itself. Since there's a variable inside, I'm going to take care of that. So that means we got to get rid of the 3. So this 3 has got to go. Since it's a multiply here, 3 times the absolute value, we're going to do the opposite, of course, use that inverse operation, and we'll divide. So I get 8 equals the absolute value of x plus 8. Split it up into our two cases. So our absolute value term of x plus 8 could equal 8. Or our absolute value term x plus 8 could equal negative 8. So let's do some quick subtraction here. This will be, bring this over here, make this a negative 8. That'll be a plus. That's gone. So x is going to be equal to negative 8 plus 8. Hey, that's 0. And over on the right side here, we'll bring this over here and make this a negative 8. And that'll go away. So I'm left with x equals negative 16. Two possible answers there. Now, something I didn't really talk about before, but it can be noted that sometimes the book likes for you to write answers like this. It's called list form. And it puts it in these curly brackets. And it kind of goes in numerical order, least to the greatest. Just in case you see that, that's what you know it's coming from. I'm not really a stickler on that, but if you see the list brackets and they want answers like this, that's what they're talking about. They're just asking you for the list of answers. That's what these are for, to show a list. And that's what this is, just a list of numbers that x could possibly be. Okay, another one. This one is a little more complicated. Again, we're trying to get this by itself. So I think the best thing to do here, well, let's get rid of this positive 3 first. And I like to get all my numbers on the right side and then multiply and divide first, or second. So that's going to make this a negative 3, and that's going to go away. So down here I'm going to have 33 minus 3, that's 30. And then over here I'm left with this x minus 12 and the absolute value times 6. So once again, just like we did in the last couple examples, we're going to get rid of this 6 by dividing. So now I have the absolute value of x minus 12 equals 30 divided by 6, which is 5. So we'll split this up here into two cases. X minus 12, our absolute value term, could be 5. But x minus 12 could also equal negative 5. So just a quick one step here. Add 12 over here. Get rid of that. I'll slide over here. Add 12 over here. Get rid of that. So on my left side here, I have x equals 5 plus 12, that's 17. So that's good. And then over here, I get negative 5 plus 12. So signs are different. We're going to subtract the sign of the bigger. That'll be a 7. So again, if you haven't caught it on by now, here's the steps for solving an absolute value equation. We're going to use our inverse operations to isolate the absolute value expression. We're going to rewrite the resulting equation as two cases. One's going to be positive and one's going to be negative. And then we're going to solve each of those equations and get the two answers. Sometimes you're going to have maybe one answer, and sometimes you're going to not have any answers. So let's take a look at this first one here. This is going to be the absolute value of x plus 3, and then plus 4 equals 4. So we're going to do the same thing. There's nothing different here that changes in our operations. Just your answer is going to be a little different. So here's my x plus 3, and I got to get that by itself. So that means I got to take this 4 and toss it to the other side and make it a minus 4. Okay, so that's gone there. Now I have the absolute value of x plus 3 equals 0. So I've isolated my term. It's all by itself now. I'm going to split it up into two cases. So my x term could be, or my variable term, how about my absolute value expression? That's better. Could be 0, but it could also be x plus 3 equals negative 0. Well, hold on, that can't work. We don't have negative zeros, so this doesn't work. So in this case, we're only going to have one answer. How about I spell it right? One answer for this. Because I can't have two different cases where it's positive 0 and negative 0. There is no positive and negative 0. There's just 1 0. So I'm only going to have one answer. I'm going to subtract this 3 and bring it over here. There we go. Move it over. So I'm going to be left with x equals negative 3, my one and only answer. Here's another one here. Same procedure. We're going to get this term by itself. So that means taking this 8 and getting rid of it, moving it over here. That's a plus 5. So negative 8 plus 5, signs are different. Subtract, keep the sign of the bigger number. That's going to be a negative 3 equals x plus 2. Now, before you go splitting and making two cases, one thing you always have to remember is the absolute value is always positive, right? Always a positive. But in this instance, look, this number is negative. And we can't plug in any answer that would make this work. If I might have figured this out and I said, well, wait, what about x equals 1? All right, if I plug in x, or 1 for x, 1 plus 2 equals negative 3. Okay, that's absolute value of 3. What's the absolute value of 3? It's 3, and that doesn't work because it's not negative. So that's a big no-no. Doesn't work. So whenever you see an absolute value term or expression that equals a negative number, right here we do, this is a no solution. No solution, because we have an absolute value expression that equals a negative number. It's just something to keep in mind for. You might want to split it up and do that, but trust me, it's not going to work out for you. Okay. Here's another one. I got to get this alone right here, the absolute value of 2x minus 5. So I'm just going to take this and bring this over here and make that a minus 2 and say goodbye to that. So now I have negative absolute value of this equals 5. Now, one important thing here to mention about this negative that's sitting outside. I can't distribute that in an absolute value. It doesn't work like that with absolute value. You can do it in parentheses, but you can't do it in absolute value. So a lot of people like to remember that this is a negative 1. So to get rid of that, we're going to have to divide everything by negative 1. Okay? Just remember, you can't distribute, you can't have a negative, so you got to get rid of it. Now, when I do that, this will go away and this will go away, and I will be left with the absolute value of 2x minus 5 equals, now 5 divided by negative 1 is negative 5. But here we go again, we have an absolute value equaling a negative 5. And right away that's a no solution. But if, again, you make that mistake and you do, okay, well, 2x could be negative 5, or 2x minus 5 equals negative 5. And I solve, and I bring this over here, and this is gone, and 2x now equals 0, and x divided both sides by 2, and x equals 0. Well, let me just take that one answer here and just check why we're not going to get the correct answer. 2 times 0 minus 5 equals negative 5. 2 times 0 is 0, so that's gone. So the absolute value of 5 equals negative 5. Things may be looking good, but remember the absolute value of negative 5 is just 5. And 5 does not equal negative 5, so it won't work. So once again, this is a no solution. Another one here to look at, we'll get through this one quite quickly. We'll take this negative 6 over here and bring it over here and make this a positive 6. Now, before you did that, if you notice, okay, wait a minute, Mr. Schaefer, this is a negative 6. Can't have that. That's okay. You haven't isolated the variable yet. So don't jump to conclusions just yet. So negative 6 over here makes it a positive 6. So that's going to go away. I'll have x minus 4 equals negative 6 plus 6, that's 0. And now I have my isolated absolute value, and that's okay, and it's equal to 0, and that's still okay, because now I'm just going to have one solution for this, which is going to be x minus 4 equals 0, not a negative 0, don't need two cases, just one. Add the 4, x equals 4, one and only answer. Okay, we're going to look at some word problems. We won't do too many of these because they kind of get redundant. So this is the Sydney Harbor Bridge. It is 134 meters tall, and the height of the bridge can raise or fall by 180 millimeters because it changes temperature, and that's just brought with every road and every bridge. Write and solve an absolute value equation to find the minimum and maximum heights of the bridge. Now there's really two ways we can go about doing this. We can actually, well, first we'll have to do this. We'll have to convert 180 millimeters into meters. And without going in crazy into any conversion factors, 180 millimeters, you have to divide by 1,000 here. And that's going to get us 0.18 meters. Okay? So let me erase this here and make some room, because I'm going to need quite a bit of room here. Where'd that come from? Erase, erase, erase. 0.18 millimeters. Or meters. Okay, great. So when I think about it, my height of the bridge is going to be 134 meters tall. And it's going to be able to increase, okay, by 0.18. Or I can have it 134 meters and I can decrease it by 0.18. So it can change because by the temperature those amounts. So let's just really quick, let's figure out what those values are. 134 plus 0.8, that's going to equal 134.18. Fair enough, I'm just taking that and adding it on. If I'm subtracting, I kind of ran myself out of room here. If I'm going to take 134 minus 0.18, that's going to give me with 133 point, squeeze it in here, 82. These are in meters. That's fine, but we're really still asked to figure out what's our expression going to be like. What are we going to write? How are we going to write an equation? All right, so what this is going to look like, I'm going to take my starting value, 134, minus x, the change of the bridge height. And that can't be any more than 0.18. That's our change. So what I'm going to do here is we'll solve it real quick. That's what our variable term is going to look like, but we'll solve it real quick. Again, two answers that we can have. 134 minus x could be positive 18, or 134 minus x equals negative 0.18. So I'm going to do this. I'm going to subtract, bring this over, make this a negative 134, and then I'm going to have, that's gone. Probably going to run out of space. I hope not. So negative x is going to be 0.18 minus 134. So that's going to be negative 133.82, familiar number. And we'll divide both sides by negative 1 here just to get rid of that. So x is 133.82. That's one of our answers that checks out. Over here we'll do the same thing. Take this and we're going to make this a subtraction. 134. So negative x equals negative 0.18. Well, let me do the math there. I don't have to rewrite it. This is going to be negative 134.18. Divide both sides by negative 1. And x comes out to be 134.18. Are two values that we found by just using some logic here and figuring out without the expression and the whole equation and everything. But in some cases, I hope you probably will see one of these on the Keystone exam to write an equation that looks like this. And really, this is the change. This is like the allowed change we're given. This is the start. And this is going to end up being the final height. Okay, that's the end of this lesson. Here's some final lesson questions here that I want you to look at. There are 5 regular equation ones, and there are one here with a word problem. Please do your best on these. If you have any questions, of course, always just let me know. Thanks so much again for watching. I always appreciate it, and have a great day.